Okay, next we will discuss on the one theorem called the parallel axis theorem atau teori paksi selari. What does it mean by the parallel axis theorem? So let's say we have one structure. So we have the centroid here. Okay. So this is the X, C, and Y, C. So that is one small element, okay, located at Y from the centroid and also X from the centroid. Okay, so the parallel axis is when we created or when there exists another axis or the reference point. So we have this parallel, so this is called the parallel axis theory. So x parallel to the xc and y parallel to the yc. So what are the distance? So this is the distance d, and this is what we call it the distance 1, and here we have distance 2. Okay, so how can we modify the previous theorem that we use? We have the ix, okay, is integration of y square dA, and also iy is equivalent to the integration of x square dA. Okay, by referring to the theory parallel axis theorem, so ix has become dy plus d1 square dA. Okay, so this is dy plus d1, whereas here you have x plus d2. So this is the parallel axis theorem. So by expanding the function, we have 2y di plus di square dA. Okay, so we can separately divide that plus integration of 2y di dA plus the integration of di square dA. Okay, so this is the conventional ix. Okay, here we have the 2 di integration of y dA plus di square dA. Okay, So now we have the second moment of area. We have the first moment of area. Okay, so Ix, okay, plus here when it goes through centroid, so this equation must be 0. So you have here the integration of a di squared. So we have finally the Ix is actually equivalent to the Ixx plus AD1 squared. Okay, this is 1. So this is the final one. So the Iy similarly by approaching the same procedure, we can have the Iy equivalent to Iyy plus AD2 squared. Okay, or the okay, that is the derivation of the Ix and also Iy for the parallel axis theorem. So let me demonstrate one example. So let's say we have the I-beam. Okay, which has the size here 40, 80. Okay, these are 60, another 20, another 20, this is 40, this is 20. All dimension in mm. Okay, so first we have to identify where is the centroid. Okay, so how can we identify the centroid? So okay, first identify the centroid. So we can use either the equation okay, and also x equal to summation of xa equal to summation a to get the centroid. Okay, so how can we solve this? So actually we can use another approach. We can also put it into the table. Okay, we identify the parts, we identify the x, the y, the A, also XA, and also YA. Then this is summation of A, summation of XA, summation of YA, which eventually will be used here. Okay, to obtain this, we can apply in various ways. There are no limit to one approach only. For example, I will demonstrate you the first approach, whereby we approach 1. How we solve this? By using the plus method. So we can separate it into 1, 2, and also 3. So meaning that we have the 1, so this is the center, plus the 2, okay, 1, 2, and then plus another 3. Okay, maybe we can also try in approach 2, where we have the whole block, okay, comprised of the size 80 for the width, and also 60 and 100, but we eventually minus, okay, we minus the left and also the put it, okay, the left and the right side of the wing, which is actually this part. Okay, this is 1 minus 2 minus 3. This is 2, this is 3. So you can choose either approach 1 or approach number 2. There is no specific approach. Please find the simplest or the easiest for you to attempt the problem. Okay, so let's say we try into the first approach. The first approach, using the first approach, okay, luckily the centroid located at the center of the part, because everything is symmetrical. Okay, due to everything is symmetrical, so the centroid is happen to be at the point of center. So, and then how can we solve the problem? By introducing the Ix and also Iy. But in this case, where it rotated, if it rotated through the x-axis, so we use the ix. If rotated through the y-axis, then we use the ix. Okay, so ix equivalent to the summation of ixx plus ad1 square, meaning that we have the ixx for number 1 plus ixx number 2 plus ixx number 3. We have to do it separately for each individual part. Okay, so in this case, so we have the ix1 plus ix2 plus ix3. So what is the ixx1? So again, we ix, the equation which is the ix, oops, sorry, the ix, no, it's not the ix1 plus ix2. This is the ixx plus ad1 squared. So this is referring to the bh3 over 12 plus ad squared. So what are the d? So bh, let's say for the first part we have the here the 80, the 20, the half of it is 10, located at how many distance from the center to the centroid. This is the centroid. So this d1 equivalent to 30 plus 10. Okay, so what, this is the ix1, and then the other one is the mathematical order, which is the b is 80, h is the 120 square divided by 12 plus ad is 80 times 20, t is 40 square. Okay, and then you can get the answer for ix1. For ix2, this is the ix1. For ix2, represent the center part. Okay, so this is 40, this is 60. Okay, the ix2 is equivalent to ix plus ad1 square, or call it the id2 to separate for part 1 and part 2, equivalent to bh3 over 12. Okay, again here there is no distance between the d and also the centroid, because it happened to be at the same point. So there is no d. The d is there, the size is 40, 60, but the d is 0. So you have the ix number 2. For number 3, again, the location is located downside. The symmetrical effect here similar. The size So we can call it the ix1 is similar to ix3. Okay, but to ensure, we put it as the equation plus AD3 squared. Okay, the B is 80, H is 20 cubic divided by 12 plus 80 times 20, and the distance is 40, or you call it can call it negative 40, but you square it, so it happened to be the ix3 and also the ix1 is similar. Okay, so and then you get the i3 here. So the total ix for this particular dimension is equivalent to the ix1 plus ix2 plus ix3 by using the first approach. Okay, what if we are using the second approach? Okay, the second approach says that we have the whole block 80 times 100 minus the left side and also the right side with dimension 20, 60. Okay, the equation is still same. The ix equal to the ix1, we call it 1, minus ix2 minus ix3. Okay, the ix1 refers to bh3 plus divided by 12 plus ad square dd1 minus bh square plus ad2 square, and then minus bh3 square plus ad3 square. Okay, what is d1? What is d1, d2, d3? Okay, in this case, all the point happen to be at the same centroid point. Okay, so the center of 1, 2 and 3 is similar to centroid. Therefore, there is no distance. So d1 equal d2 equal to d3 equal to 0. So you just solve the equation by using the bh3 12 plus 0 minus bh3 12 plus 0 minus bh3 12 plus 0 due to no distance. So and then it is all mathematical. The 80 plus 100 divided by square minus 20 times 60 divided by 12 minus 20 60 divided by 12. So we can get the final I for this particular part. Okay, previous problem can be regarded as simpler one due to symmetrical shape. So what if we have non-identical shape, non-symmetrical? For instance, example 2, we have a T shape problem. Okay, with the dimension of 90, here is 20, and the height here is 40. Okay, so find the I for this part. So how can we solve the problem? First, we have to identify the centroid. How to find the centroid? You can use the table. For easy. Okay, this is part, this is x, this is y, this is a, this is xa, this is ya. This is summation a, summation x, a, summation y, a. So we identified as part number 1 and part number 2. So the centroid x is equivalent to summation of xa divided by summation a, whereas dy is a summation of ya divided by summation a. Okay, so here we have several approach. So what approach you use? Number 2, what approach you use? Let's say we have for the first approach, I like to put it like this: 1 plus 2, or I can also use the whole block, and then I minus the left side and also minus the right side. Here, the left side and also the right side. So I have here 1 minus 2 minus 3. So extra part to be considered. So in this case, I will opt to use the first part rather than the second approach. But still, you can use the second approach if you are familiar or you feel easy to do with that approach. It's no problem. It's just very extra care when you deal with the y and also the d. Okay, so let's say we use the first part, the first approach, which is the plus approach. So by using the same blocks here, you have part 1 and also part 2. So part 1 is equivalent to, what is the x, where is the y. So you have to initial second to set the axis. See, so in this case the x-axis is here, the x, and also this is the y-axis. So what is the center for first part? Somewhere here, 10 mm from this part. Okay, for this part is half of the 40, which is 20 from here. Okay, what is x? Okay, so let me put into another perspective. We have the first part here with the size of 90 and also 20, with the center of 10 located 50 from the center to point, and then plus the second part with the dimension of 30 and 40. The center is located 20 from the axis. Okay, so put it into the table. This is part 1 and 2. This is the x. Okay, we have no x, actually we have y. Okay, this is the y, this is the area, this is summation, this is the ya. Okay, this is the ya, this is the summation of a, this summation of ya. So we need to find that the y centroid, the y A divided by summation A. So y is 50 for part 1, for part 2 is 20. The area is 90 times 20 for part 1, 30 times 40 for part 2. So what is the YA? So and then you can get the answer is about 38 mm. So meaning that the IX or the centroid for this part is actually 38 from the bottom line. So this is the centroid point. So this is the center 1 and then this is the center for number 2. Then you can solve the problem of IX equivalent to B what you call it, the IX1 plus IX2, which is the BH312 plus AD1 squared plus PH cubic 12 AD2 squared. So what is AD1? What is D1? Is referring to the here is D1. And the centroid to the center here refer as D2. So D1 here is 50 minus 38, you get 22. Oh, not 22, the distance is 10 plus 2, 12 m. For D2 is 38 minus 20 is 18. Any equivalent to 50 minus 38. This refers to 38 minus 20. Then everything is the mathematical. So IX equal to B for part 1. We have the 90 plus H is 20 cubic 12 plus A is 90 times 20 and the D1 is 12. Okay, and then plus this is the for part 1 and we have the part 2 is B is 30, H is 40 cubic divided by 12 plus A is 30, 40 plus D2 is 18 squared for part number 2. So you have the total IX. Okay, so this is the approach 1. So you can try your own for the approach 2 and tell me if you have the same or different answers. So this is the end of the session. So once again, thank you. Assalamualaikum warahmatullahi wabarakatuh.